So my goal today is to talk a little bit about STEP 242. And so I'll do a corporate overview. In this particular presentation, if you've come to some of our other presentations, you'll notice that we'll spend a little bit more time on the PowerPoint versus the actual technical presentation and demonstration, but hopefully you'll get an idea of what model base is and what's happening out in the industry and core technologies involvement to the STEP 242 and the AP 309. Also, the goal of originally where this started from was to create a standard format for model-based engineering using the LOTAR standards in the industry, which you'll learn about. So a little background on what you'll learn today again is why not 203 and 214 that's widely used today, and assisted in the technical package, as well as STEP AP 242 convergence for the 203 and the 214. So here's a list of our customers that are currently using our technology. And a little bit about our products that we've brought to the market. We've brought 3D Kernel I. This is a software development kit, and you may be using it today. A lot of companies like Altair Engineering, MSC Software, PTC, they all have libraries. When you hit File Open, you open up a CAD model, and it's normally using libraries that core technologies in the industry have implemented into these different software applications. Also, we've taken that same set of libraries and embedded it into our own products. And today we're going to focus on 3D Kernel I/O, but everything that you see today that is done in 3D Kernel I/O can also be done on our software using 3D Analyzer from that. So here are the list of native and non-neutral file formats that core technology supports. And keep in mind that we support this from reading from the APIs and not reading from the binary code and not from the APIs of the CAD software, allowing us more information. And more specifically, if you think about composite data, that's not something that's offered in the APIs. Also, publications from CATIA v5 and some other entities from Creo and NX is also supporting our technology that's not supported from the APIs. So being able to hit File Open and reading those files both from a boundary representation as well as a fully parametric model. Everything that we're showing you today can be completed in batch process. A lot of our customers are asking for data translations with specific healing capabilities attached to it and being able to write a script, and we do that extremely well. Not only do we offer a batch process outside of the PLM, but we've integrated into a lot of PLM applications around the globe with most of our customers. And so why the standard format? As much as we think we can all just use one step file or use one CAD system, we keep on thinking to ourselves that this is going away because a lot of the CAD applications have the ability to read their competitor's product. But the truth of the matter is that multi-CAD is not going away, and it's becoming more complex because when using standard neutral file formats, it may not include the information that you are required. As an example, maybe like a density information that's not supported and writing out just a standard step file. So we include the complexity of those requirements and understand the target system when it's going around the globe in communications on the 3D model. And model-based engineering is obviously becoming the de facto standards in the industry. And so how did the birth of STEP 242 come alive? If you look at the center, where it says the AP 242 model-based engineering, there was an overlap between the 233, there's an overlap 239, and then also the overlap with 230, AP 239 and the 214 and 203. And so what we wanted to do is start encompassing more information through the product lifecycle, being able to have the ability to read in one step file format that includes the information that's required for all downstream applications. And you'll see later on in this presentation how Airbus completed that task. And so at the end of the day, a lot of folks may call it the digital thread. In the case of using it with the LOTAR consortium, which you'll learn about, they use the word the digital enterprise. And that digital enterprise or format is the mission to be able to handle both the model-based engineering, model-based manufacturing, and model-based sustainability, as well as being able to hit the business side as well, and be able to hit the ability for folks that need to read CAD files that don't have access to the CAD system. So it's an independence of any other languages. Talk to you a little bit about PDIS if you haven't heard of it. It's a consortium body that encompasses a lot of different companies, mainly in the aerospace industry, but a lot of the different CAD companies also are involved in this consortium. And the idea is that if there's a requirement that's coming from a company like Airbus or Boeing or Solar Turbine or Caterpillar or General Motors or Ford Motor Company to include in that STEP file, instead of building that STEP file themselves, they come to our consortium and then we build it based on the ISO standards. So that's the key point here, is that anybody can take and build any type of STEP consortium on their own, but the idea is that if you're building it up as a standard, the entire industry can consume that data for downstream applications. Here's a little idea, give you a little idea of the representation from the board as well as the TAC. And the TAC is the technical representation, and you'll see a little bit more about how we handle the technical aspects of writing the statement of work from requirements from Boeing or Dassault or Gulfstream or Jotney, Lockheed Martin, just to name a few. And then how that works downstream from writing the statement of work to going to the CAD-IX folks. And so the overall standards and the link with the associated ISO standards, and just because it's not necessarily like the edition, we're currently utilizing what is called edition 2, just because we're in the process of developing the edition 3, it could have a lot of the functionalities based on the projects and the scopes of that edition, but it may not yet be ISO certified. So it's in the process of being ISO certified, and there's a whole methodology that the TAC team uses for that. And so a little bit about the business planning and timeline. If you notice, this was 2019. So this kind of happens, this does happen, not kind of, it happens every single year where we have a kickoff in April. We draft proposals, so ideas of what we want to include in the STEP 242 file or the 209. And so what we do in that case, in those draft proposal, as an example, maybe there is a requirement to include wire harness data or mechanical information. So we decide what format it's going into, and then we push that over to the TAC team and say, okay, here's our statement of review, a statement of work on those particular proposed projects, and then let's find out who has an interest from there, and then those parties from the consortium would join those lead reviews and then go into priority of the different projects that are taking place. And then after those are set, an assessment and adjustment is completed, and then the board completes and reviews and approves the actual projects themselves. I'm going to show you an example. Oh, I got one more slide before the examples. So the planning milestone is set as well. So what was done, number 2 in here, you can see the ISO 10303 5-year roadmap, and then the different entities and the processes that and the timeline that it takes. And these are some of the LOTAR's 5-year development roadmap of the specific project. And then this is a list of those priorities based on those projects. So this slide kind of explains, once you write the statement of work and set up those particular projects, then it goes to an expert of teams based on, so there's the LOTAR that writes the standards for long-term data retention. And then the next step is to send it off to the CAD-IX folks. And so you can see Core Technology is listed here. One of the competitive advantages that Core Technology has over the other consortium parties is that we've partnered with a lot of companies on the composite data, as we know, in additive manufacturing, as well as downstream applications for just standard manufacturing, is composites becoming extremely important for when you're analyzing excuse me, on the actual data itself, so CAE analysis, if you will. So a lot of times that composite data is extremely important on mass properties. And so this is the slide that I was talking about earlier. Is this is just one example of the model-based systems engineering. So this is a specific project that we talked about, and we write out the scope of those projects, the objectives, and then the participants that are related to those projects. In this case, it's Airbus is interested, BAE, Boeing, Embraer, just to name a few, Lockheed Martin. So the idea is that if you're a part of the consortium party, you're not doing this alone. You're doing this as a team. So you're accomplishing more with less people. So if you think of this particular project alone, it would take 5 resources within your organization to do it, and now it's done with just 1. So because the other 5 are coming from the industry. And then there's a major deliverables by quarter. And so in addition to those particular projects, they're also set up based on the technical work groups as well. So you can see the different work groups from visualization to composite and advanced manufacturing, which I talked about. And so this particular requirement is in the step 203 and the 242 edition 1 and edition 2. So this was just released in the 203. This should be quite an interesting one. And I know that Gautier is on the call with us, but he was involved with the engineering analysis for the 209, and we did release the 209 and have that available. Wire harness should be quite interesting as well. And so a little case study to kind of show you what has happened in the industry in the past. So Airbus, as part of the consortium party, said, okay, you're CADX folks, let's see exactly what you can come up with, because we're going to start implementing this as a neutral standard file format. And our idea in our head from a top level is to be able to take it from the preliminary development within CAD, writing out that CAD file to a step 242 file, run it to the engineering department for testing and analysis, then running it out for production planning to see if you can get some quoting on the step 242, and then going it to the next step from tool manufacturing, and then doing quality control and inspections on the actual CAD file. And the idea with this test and testing it ended up being a very successful test. And if anybody's interested, I have probably 2 or 3 papers. One of them is from NIST that Core Technology was involved in doing a study to see whether or not you could take a file in the AP 242 and meet all of the requirements from computer-aided engineering to computer-aided manufacturing. And that was a very exciting project for us. So here are just some scenarios that are used in the industry, from doing, a product data quality check to converting the file to a step file, and then creating that neutral file check, as well as validating the check in the properties. So a typical workflow for Airbus was to take the original file format as noted in the previous slide, either use the original CAD file to write the step 242 format, or to use Core Technology solution, send it off for what we call the VDA GVP property checks. So the standards that are required to validate that the model is accurate. Does it have the correct geometry? Does it have the number of the correct assembly? Are all the parts information is correct? And you'll see that in the next slide on exactly defining what that GBP check is. And does the file need to be healed or clean? And if it's okay, or it would go to the next step. And so the idea of this is that it meets those long-term data retention. So from manufacturing, as long as nothing got changed in the design itself, that file format could be used to be consumed up to 75 years later, where a lot of the CAD systems, and if you think of CATIA v3 and CATIA v4 and ideas data, none of this information can be consumed right now because of the workstation that's required to hold the information or open up the file. And that's part of the reason why this STEP 242 is. The other reason why people are using STEP 242 is if you have somebody using a version of CATIA v5, let's say R29, then you have another version either internally or externally. You have someone using an R26. How do you communicate those two CAD systems? Because R29, you cannot open in R26 format. And so if you look here, this is where Core Technology has the capabilities to convert into validate. So I want to talk a little bit of how the industry is handling and the objectives as it relates to model-based engineering. From a technical side, it's about Pmi. They no longer want to print paper. They want to be able to take in their manufacturing floor or using an iPad, if you will, and be able to read a file and absorb the information required. And then from a cost side, the idea is that we have seen the reduced efficiency gains of up to 50% using 3D models versus a print model. And so the idea, again, also is the folks using this technology feel from a culture standpoint that it's actually more information rather than less information, because you can't take a 2D drawing and calculate mass properties or look at density information or hone down and understand how many areas of the part of pages you're flipping through, pages and pages of information to get the Pmi information on a part to see the consistency for building that part itself. As a Core Technology can complete this task from the AP 242 from a semantic representation. And let me explain to you a little bit about what semantic representation of Pmi. So product management information is considered to be the associativity of the Pmi with the drawing itself. And when we talk about the associativity, and Marco is going to show this to you in his presentation, when you click on the actual 2D the Pmi data, it will actually touch where exactly it is located. And that's the advantage of the semantic representation. So this is a list of some of the properties that are written based on the long-term data retention requirements and then absorbed downstream for the validation checks. So the question is that from a validation standpoint, when you're confirming all the information is properly stored in the information, we can check for the geometry, annotations, assembly, saved views, which could be a big one when you're dealing with 3D geometry versus 2D, user-defined attributes, color, visibility, and the conversion of a report to say that it was successfully done. We also give you the bill of the formats listed below. And so Core Technology can currently meet all of the requirements based on those standards. And this is just an example of a report that we would give you. In addition to the long-term data retentions, the validation properties that I talked about in the last slide, we also can take the geometry and compare it from the geometry, the assembly, the Pmi, the features, the attributes, and a couple that are not listed here are doing a linkage check as well. So there's a lot of checks that we've added in the industry that are failed in a lot of the CAD systems. So I'm going to pass this on to Marco, and I will have him show a live demo.
Okay, can you see my screen?
Yes.
Okay, so David already spoke about the importance of a neutral format that is capable for the model-based enterprise. So I'm going to talk to you about how exactly we come into that space with our ability to read and write STEP 242. So I'm going to start by reading a Creo part into 3D evolution. For those that have been following us, we have been looking at 3D Analyzer before. Now we are using 3D evolution. And one of the differences is that we're able to actually save out parts in different formats with 3D evolution. So we are able to take any format file, and we can see a small list of the different formats that we support in here. We got CATIA V5, V4, we got Ideas, Inventor, Astra, NX, SolidWorks, Rhino, STEP, AGES, and pretty much everything under the sun we got in here. So we can read any of those in and convert to STEP242, which is what I'm going to do right now. I'm going to take this part here. I'm going to convert this to STEP242, and that means making sure that all of the geometry definitions here are compatible with the format. I'm going to go ahead and run it. And it's been converted. It doesn't have any problem. I just want to make sure that my settings are correct. So in here, this is where we set up the different configurations for STEP242. You can see it is one of the protocols that we have enabled in here. And if we want this to be self-checking, I'm going to explain how to do that in a bit. We need to enable the validation properties. So doing a self-check or doing a Gbp check is very much like doing a comparison between your inventory records and your physical inventory. You're checking something that you're supposed to have in one record towards something that you actually have physically. So for each one of these checks, there are different categories. The ones that I will show in today will be geometry check, assembly check, and Pmi check, together with semantic Pmi. So for this one, we only need geometry check. And then I'm going to go ahead and save it as a STEP242. And we're going to see how this gets saved in here. So once this is created, I'm going to drag it over into 3D Evolution again. This is now a STEP242 file. There we go. And a very good way to know what kind of format this is to look at the properties of the part. 3D Evolution gives you all sort of properties on it. You can see that this is a STEP file. Or this is your name, all the properties, all the metadata is in here. So what's special about this STEP242 part is that when it was created, the validation properties were embedded into it, which is like taking notes of the inventory again. So some of these properties already are part of this geometry. They're not showing because they're internal, they're embedded. But if we go into our checking module, we go into our Gbp check here, and I'm going to show you the configuration just so you take a better understanding of what's going to be checked. So under the geometric validation portion, these are the properties that are automatically generated and checked. So when I save this file, allowing the geometric validation properties to be saved, all of these properties were generated and saved just as they are supposed to be before converting. So when the file was saved, all of these records were part of the file. Now, when the time comes to read this file in, all of these records are still part of the file. So you are able to recalculate this again in real time and then compare against what you had before. And then you have a measure of how much it changed. So if it changed less than the threshold that we have in here, then we consider this to be a successful translation or a successful derivative of the original one. So we're going to go ahead and run the Gbp check now. Okay, so this is just an overview. We have 0 validation errors. That means that this is a perfect derivative of the original. It's actually past test validation, but if you want to see the details of that record, we get into our reporting here. Then we have checked the following categories. So when this was saved originally to STEP, this is the area that it's supposed to have. When I read this in and calculated the area again, this is what I read. So by comparing these two, we see that the deviation is minimal, It's almost nothing. So obviously this is a pass category because it's green and the value is small enough. So the same goes for volume, center, bounding box, and diagonal, and the number of independent points. So these are your geometric validation properties. And if you can see, or you can notice, you don't need the original, you don't need the source part to validate a derivative part if it's step 242 with GBP, because the properties necessary for validation are already in here. So that's one of the beauty of the step 242. You don't need to carry around the original to be able to validate that part. These properties are checked at various levels. So we have one check at the part level, which is this, then another check at the body level. So if you have multiple bodies, you will have multiple checks of this. So it's very reassuring knowing that there's a level of co-validation between the sum of all the individual body levels and the actual part level results. So it is self-reassuring. So this is a report that you will get. In here you can see the configuration of what was checked. So of all of these categories, you remember when I was doing the configuration of the checker, I only ticked the geometric ones. So these are the ones that are thick. These are the only ones that we check. We have a lot more categories, but in this case, we didn't check it. Assembly is usually part of the check, but PMI, well, there's no PMI in this, so there's no PMI to check. So if a particular feature is to be checked and it's not present, it's not going to cause a failure. It's just going to be ignored because there's no information to either say if it's good or bad. So this is how you would check a part, a step 242 part, to make sure that it matches the original. There's another concept which is called the assembly checking or Gbp assembly checking. Now this is a little bit mind-blowing because you can actually check an assembly without necessarily having the whole assembly structure, and that's part of the abilities and capabilities of a step 242. And I have a great example in here.
Yeah, Marco, can I ask a couple of questions before you go into that? Because I think those questions need to be answered to get the
go ahead.
So one of the questions, at least from my experience, every time you translate something to another format, you lose data. Like translate from one software to AP 242, go into another and translate out. Also, different translators give you different results, like out of each software, how they meet 242 requirements. The answer to your question is yes, you are correct. And the reason being, I had mentioned differently on the one slide, is that core technology step 242 tries as actually validated and certified to give you the correct results going down, and that is the reason for you to do the validation check that he just showed you. So hopefully that answers your question, Brad. And then the second question that came up also would be interesting in the project for the NIST, where it showed up how step 242 worked in all those areas. I should preface, yes, I will send that out. I have to research where I put that document. It is probably about a 35-page document. I personally was involved with the project and seen it through the process. I do want to say, although that it did show positive results in the process for the validation all the way through manufacturing, you'll see listed in that paper some of the gaps as it relates to the AP 242. But the idea is that it's further along than the 214 and the 203. So hopefully that answers your question, Brad. And then another great question is coming from Raymond. It says, what is the advantage of using core to export 242 rather than the native? And it was kind of answered in the previous question. So core technology, the advantage is twofold. Number one, we meet all the requirements specifically for the composite data, some of the other CAD systems that have been implemented. So like if you look at, I don't want to mention one of the CAD systems without beating them up a little bit, but let's just say all three of them are using the same step 242 format. They may have a failure in their process. So I know I don't want to beat them up, but it's happened where they had a failure and then we wrote out the same file and we showed success because of all the testing that we do on our side. So there is a variations of that CAD format, and then so that's one advantage. The second advantage is that core technology has the ability to heal the geometry based on a specific tolerance. So if you're writing it out from CATIA, it's written out thinking that you're also going to open it up in CATIA, when the truth is that you're using it for other downstream applications. So the model is not healed from a geometric standpoint or a topology standpoint. So core technology will heal that model to create consistency on downstream applications so that you don't end up having imprecisions or non-solid model. Hopefully that answers your question. Healing is dangerous. Good follow-up. Not a fan. So, you know, I have to mention this because you're 100% right. And I got to mention a project that I did. I did a project where we were at Chrysler, which is a reference account, and we were writing out all the files and healing all the models. And we were required to validate the model from both the geometry standpoint. So it wasn't even validating based on the validation properties, and we ended up having something like a 60% failure. So we had to remove that healing capabilities, and they had to deal with the idea that we had to have a precise, no false positives, if you were, even if you're moving a face only to a 0.01 tolerance. So that that's a great comment, because that's always the argument, because if you're reading a file from the binary code, you're reading it as if it was represented in that CAD file, but when you're writing it, it is changing it. And so in the case of Gulfstream, they actually did a study where they did a triple validation. It was, their process was very detailed. But thank you very much. Go ahead, Marco.
David?
Okay.
Yeah, can I add something, please?
Yes, please.
Just to answer more to this question of why use core to export 242, I have a very simple example based on a huge company that makes airplane in Europe. So you can imagine that this company is still using, not today, but months ago, they are still using CATIA v5 R19 internally. So when you want to output the latest AP 242 with this CATIA v5 R19, which is a 10-year-old version, then you just can't. You need to use a newer software. And if you use also, in such a company, you have sometimes people that are still using very, very old CAD data, like CATIA v4 or CADs, or software that do not exist anymore, and where AP 242 is just not an option. Then with our solution, you can still output AP 242, whatever is your CAD system. This is a big change.
That's a good point. Thank you for jumping in, Gautier.
And on top of that, I would add that, which is very relevant to both questions, that we can save that step 242 in several ways. One will be our way, which is perfectly compliant with the standard. So that will be saving in evolution step. But we can also flavor that that particular step to an implementation, because we know that not everyone has a perfect implementation of a step 242. So we can flavor it for a particular application, like for CATIA v5. So we know that if we know that CATIA v5, or we know that Creo, or we know that SolidWorks has some problems with reading the full implementation of the step 242, then instead of saving it as evolution step, which is a perfectly compliant version, we save it with a slightly flavored version, which will be SolidWorks step. And now we know that this version has been made specifically compatible with their interpretation of the implementation. So that further helps getting the data across. And it's another advantage of using this system instead of using the native ones. So that will be it for that part. Now I'm going to talk about the validation of assemblies. So as I was saying, it's crazy how you can validate an assembly without the components, but it's possible, and it's actually how this was designed from the ground up. This is actually a documented use case of a STEP 242. You can see in here that I have only the top level object. I don't have the children in here, so I'm missing part 1, 2, and 3. Yet I am still able to run the validation. I'm going to go in and do a Gbp Assembly Check. Let me show you what's going to be checked first before I go ahead. So when you go into validation, we get and see what we're checking. So we're going to check the notion of solid center, which is basically the centers that the parts will cause to be if they were in the assembly, and then the number of children. So these two independent properties have been deemed a reliable way to validate a full assembly without having the children. And let me go ahead and run it. So this particular example has 0 validation errors. Let's go in and see our report and see what we are checking. So within the assembly, the assembly category, this is what we check: the number of children and the number of solids, of notional solid centroids. Then for our 4 parts in here, let me open up the details. So we are checking that all of those 4 parts created this solid centroid when this was created originally. And with the information that we have, we are able to recalculate those numbers. And then again, we get numbers are almost 0 difference to the original one, which is pretty much 0. And then the number of children reported when this was created versus the number of children that we can confirm was created with this assembly, the difference is 0. So we're reading 4 against 4, so we know that this is a good validation. Not every time this is going to be a good validation. There are certain times when an assembly will not be created correctly. Of course, there's room for failure when you create a file. I'm not saying that with 3D evolution. 3D evolution is perfect. But with other systems, for example, let's consider the possibility that there was an error when creating a file. So let's do a check on it, and this is an example where the number of children is being reported as having 1 error. So let's go and see what this means. We go into a validation report, then we see that, oh no, we were supposed to have 5 children, but now we can only count 4. So evidently one child is missing. So this is not good. Instead of being okay, this is KO. So this is a situation that we can definitely detect, or that the implementation of a STEP 242 Gbp can detect, and so we as well will be compliant to that. So this is a file that is not fully correct. It's missing something, so we know that now. So these 2 examples are in regard of simple Gbp validation. Somebody mentioned NIST before, so we're going to work now with a NIST model. And then we're going to see what we can do with that. So let's bring it up. So we see what we have several annotations in here. We have some Pmi. We have our feature control blocks. I think I'm looking at it from the wrong side. Let me turn it around. There we go. So we have a number of Pmi here. Most of these will be semantic, as David explained. You see how when I select the control block, all of the data associated with it, the BC get highlighted. So that means that there's an intelligence, and these are smart nodes. These nodes actually modify or can drive the geometry if necessary. This could be read by a CMN machine or maybe a numeric control machine, and actually take these values into consideration when building the actual part. These are smart nodes. This is not just text laying around. This text knows what it means. It means that all of these values, and it means that it's located to this. It means that it applies to these 4. And as you go around, you can also check that this also has is references. So this is the smart kind of PMI, which is what we call the semantic in the industry. So this was converted into STEP 242 by someone. We don't know and we don't care who. All we want to do is making sure that everything that we see here is accounted for. We're not missing anything. So we're going to go ahead and run again our validation, our Pmi validation now. So for that, we have a specific check here, Pmi check, and let's see what we're checking for. So we're going to edit the profile again. So this time we're not checking for any of this. We're not checking for surface, faces, or curves. We're not checking for any of the geometric validation properties, but we are checking for the Pmi validation properties. So we're checking all of the polyline, affected areas, tessellated number of views. So this is for the tessellated Pmi. Then we're also checking for semantic Pmi. We're checking all of these type of entities. So now that we have those enabled, we go ahead and then we run our check using a Pmi check. So we have 0 validation properties. That should give us enough confidence to go ahead and know that this is a perfect derivative of the original. We want to see in detail what's going on with this part. We go into the report. And we know that out of the number of views that were originally, and these are the views right here. These views contain not only your standard top, front, right, left views, but also views or MVD views created by the producer of this drawing. So originally we had 9. We still have 9, so that's good. It's okay or green. And out of 29 annotations that were reported, we were able to recognize 29 still. So this is great. All of our annotations are in there. You can actually look at them individually. You can expand them, find all the different groups and see all the annotations in there. And your saved views, they are right here. You get your standard views. And then you have a view created specifically for MVD, which still shows 29 out of 29. So all of this is enough to give us that full confidence that this is a perfect derivative of the original and it's as the designer meant. So this will be a Pmi check that we can do. We can also convert this STEP 242 with Pmi to different formats if we needed to using our conversion engine. We can convert to any of these. That's out of the scope of this presentation, but just know so we could create all of these entities. And if there's a system that does not fully support a STEP 242, so let's say that we want to write to NX, but it's an older version of NX, so we want to write to NX. Let's say NX5. So at that time, nobody was talking about annotations. We can still write this. The difference is that this will be converted into tessellated version or non-semantic, so that they can still be represented, even though there's a compromise because they're no longer semantic, they're not logic smart, but these you can make them be visible, so they will be converted sometimes into text depending on the capabilities of the target system, or sometimes into lines and points. But that is something that is optional, and you can set it up so we can always comply with the target system. So I think those were all of the examples that I have. As with all the other reports and all the other analysis that we have done so far, you can also write the report to the 3D PDF, which is what we have here. So it basically gives you a graphic window with a graphic representation of the part, and then its entities. And then you can also surf and sort the information that you want to see. You want to see at the area at the body level, and then the deviation. This is it. So you're basically looking here at the properties. You want to see the centered information. You can look at it, or the volume. So basically, these guys in here, as with all of our reports, they do exactly the same. They help you sort down the information so you don't have to be looking at a giant text report showing just numbers and numbers and numbers. This is what this area does in here.
Very good, Marco. Let me ask a couple of questions that relate to part of what you answered today, and maybe Gautier, if you can answer the first question, if possible. So the question is, thank you so much for saying, so you're saying that all systems, so Creo, CATIA, or Pro Engineer aren't meeting all perfectly the AP 242 standards? Gautier, you want to take that question?
Yeah, of course, no problem. Yes, not all the software today support perfectly the AP 242, and I will say only few really support everything in the AP 242 standard. So CATIA, for example, if you take the latest version, then you have the full support of the latest standard. But if you take the version 2 years ago, then the full standard was not supported, for example. Creo, it's still in progress and the full standard is not supported. So most of the software today do not support fully the AP 242.
And then a follow-up question to that, is there a way to know which softwares aren't as compliant?
As far as I know, you have some benchmark that are produced by, at least in Europe, by AFNet and ProStep, but I'm not sure there are some benchmark done in the US. But these benchmarks are publicly available, and then you can check and have a rough idea of who claim that they are doing something and who really support something.
Yeah, I mean, core technology does get involved. We have a presentation that we have to give on what we've implemented during the LOTAR and PETUS groups, and we receive all of the other companies' presentations as well. So we have an idea, but our goal is not to, you know, beat up and tell you the competitive situation is basically, I think Gautier's point is, we would prefer to have you complete that benchmark showing technology, showing the technology with core technology aids. I mean, we implemented the first one at Airbus, I think it was 10 years ago, so we were the first one to implement it. And then in addition to that, some of the new technologies or the projects that I listed, and I can give you that presentation, everyone that attended my full presentation that has some hidden slides in there from the report that was given from the TAC team, and it will give you all those projects. Core Technology has done like wire harness projects. We have a lot of experience in extracting the wire harness from the CAD system from the Lockheed Martin project that was published that we did for converting CATIA V4 and V5 to CATIA V5 wire harness. So we got the reading side taken care of. Now we have to figure out how can we write that same information, because wire harness is an interesting animal, if you will, but how do we write that into the STEP 242? So we're definitely will be involved in that project. And then the next question, can you use core to validate the STEP 242 received from the supplier to see if any issues, or is the validation only a part of creating STEP out of your software? And the answer is yes. What happens, and that's a great question, because there's two ways that you write out the file. If he goes to configuration for a minute, Marco, on writing out the STEP file. So if you go to configuration, just like the CAD formats, when you go to configuration and you're writing out the format, and he chooses the STEP 242, he can choose to include the validation properties or not include the validation properties which are listed. So if they're not written in the actual file themselves from that CAD system, then we can't validate them. So you have to write them out. Do you want to add to that, Gautier?
Yes. Yeah, and you know the use case, the Airbus use case you present in the tonight, it's specifically something like that. So the step file was produced by CATIA, and then we validate the CATIA file, the CATIA step file. In fact, it's not the step file we produce with our own software. So yes, the answer is definitively yes. You can validate step AP242 writing out from any CAD software as soon as it's compatible and support properly the standard and has the validation properties inside.
Yeah, that's a great question. So the next question, does it, which I'm going to have you take as well, Gautier, because this is an interesting question. So does it know enough to tell you if it's semantic call outs that says 4 times, but only connecting to 3 features? And will it flag that? So I want to add to that question. So will it also call out enough to know what is semantic representation of the PMI and what's not added to that PMI? And Gautier, I'll let you answer that.
Yeah, Marco, can you please open the check the check configuration for the semantic PMI? For the PMI, yeah, the PMI check, please. Oh yeah, this one if you want. And show me the PMI validation properties. So the answer is yes, probably, but not as you mentioned it. So there is no check that says, it says it's 4 times, but it's only connected to 3 features. But you have in the semantic PMI, the affected area or the affected curve length, the validation property. And this validation property allow you to know if the area referenced by this PMI is the same. So if you say it's 4 times and it's really 4 times at the beginning, and at the end you have only 3, then this property should be probably, and in fact should be, completely different. And we should detect that where the number of features are not the same. This is all the things are done in the validation property. So it's not exactly, we don't say it's referencing 3 features, but we say the total area or the total length of the geometrical area referenced by this annotation is a number, and if the number is not the same, then it will output an error.
Hopefully that answers your question. It is a very interesting technology to core technology. I mean, Gautier heads up our development team, so you have the correct person on the room to answer a lot of your technical questions. We might even have see if there's a way to unmute you. I don't know if this is possible, but if we can unmute a couple of the attendees, I think it might be worth it to open up even some more questions for you guys, because
everyone is currently allowed to talk, but they will have to unmute themselves via Zoom.
Yeah, Raymond, these are great questions, because when you look at really implementing model-based engineering, there's a lot of fear in the organizations to do that, because they are trying to figure out, one, what's the ROI, and then what's the advantage of it as well. So
I know that first off, thanks. It's been a great day of presentations. Been awesome. So I do know, like in a QIF format, like, so if you're working with exporting to QIF and then bringing it up into another kind of software that does something similar, it is able to pick up the semantic difference. And I'm thinking like hole or bolt patterns, right? So if you have like 12 times or 4 times, and it's missing. So say like I dig on the annotation and only 11 of the 12 highlight, like I'm not connected to 12 features, like it should throw an error. And that's the kind of check that I was looking for. Like if we're going to go down this validation road, and who wouldn't, because it's awesome, then those are the things that you need to look for.
Gautier, I don't know if you want to touch on the QIF versus the STEP 242.
There are discussion between the STEP folks and the QIF guys. There are discussion around should we integrate into STEP the QIF checking, and it's not my decision, of course. The only thing I can say is that the step around the STEP definitions, they are thinking about including the QIF inside, but the
I don't
target
want
is
QIF.
not exactly the same.
Yeah, don't get me wrong. QIF is an enabler. I would rather not have another derivative file type. I'd much rather go the STEP route. So if we can find it inside the STEP semantic PMI, I'm all over that, rather than having to have another derivative file type.
Okay.
I'm laughing in the background because I have to tell you that's exactly, our point of view as well. I mean, Gautier says, okay, do we want to, we did this eventually with our product data quality standards with the VDA versus Sussex versus all the other ones out there. And it took us a while to do it because we felt that the VDA standards met 80% of those requirements, right? And the same thing with the QIF. Where there may be an overlap, but is it worth implementing two? So we agree with you on that. And in addition to that, this being an ISO standard with the STEP 242, it's our thought is that it's better at this point in time. Someone would have to really prove it or pay for it. So Brad, you had some questions about some benchmarks. Did you want to touch on that?
Yes, so Brad, I believe, is asking for direction on where those benchmarks for the companies that do support STEP 242 and the ones that do not. Gautier had touched about ProStep doing a few benchmarks in Europe, and he was wondering if there's a way to get a hold of that.
All right, so there's a couple of ways. I mean, you'll get a ton of information. I have a paper that I wrote that I'll send to you, and in the reference, it has a lot of the links that I feel. There's probably about 2,000 papers written on it. And what I did is I took the ones that I felt that were most valuable. So I will have, I don't know who your point of contact is at Core Technology, but we'll take a look at that and we'll make sure that you get the paper, both on the one that I wrote, that's kind of more like an executive overview of what's happening in the industry as it relates to STEP 242, not showing necessarily the benchmark. And then I will also get you the NIST one that was completed over 8 years ago. So keep in mind it was older. So you're looking at from edition 2 to edition 3. We've come a long way. Do you want to add to that, Gautier? No?
Yeah, you can just Google FNet STEP benchmark, and then you will find this benchmark easily.
No. And I'll get you a copy as well, what I have. Okay. Any other questions that you guys are open to discuss? I know we're going over, but no.
No, I think that this is probably one of the most exciting areas, right? I mean, so as we're all going forward and we're trying to find this, the way to do proper validation, not only of geometry, but also of the semantic PMI that we're trying so hard to embed. So we have a whole team of people who are going above board to do all of this smart association. And so being able to check that is going to be key. It's not like super important. It's not like people are banging on our desk saying, how come it's this? But certainly we would want tools to do that.
Yeah, I agree. So it's interesting because Gulfstream was one of the very first companies in North America that did a double validation. So it's crazy, but they were only doing originally when they started 13 years ago, they were doing validation only on the geometry. And then that's when they started using that step file to validate, but they were getting too many false positives in their first process. That's the reason why they ended up doing a different one.